So far, we have explored two aspects of cryptocurrencies: the blockchain and wallets that give the blockchain additional security through digital signatures. For the third aspect of cryptocurrencies, which relates back to the blockchain itself, since many blockchains also have this feature, we have mining. Through mining, miners do the work of adding transactions to the blockchain. See, when people submit transactions to the cryptocurrency blockchain network, it takes a little time for those transactions to be confirmed and added to the blockchain. When transactions have been sent to the network, but not included in the blockchain yet, we call those transactions unconfirmed. Miners then take a group of these unconfirmed transactions and include them within a block in the chain. The actual act of mining is done through solving a computational puzzle called the proof of work algorithm. This proof of work algorithm is difficult to solve. There is a low probability of randomly solving this puzzle, so a lot of trial and error is required to find this answer to the proof of work algorithm, which is time consuming and computational expensive, which it's why it's called mining. So once a miner solves the proof of work algorithm, they gain the rights to submit a valid block containing the transactions to the blockchain. Once a miner submits a solution to the proof of work, other miners can see that solution, since this proof of work algorithm will be easily verifiable once another miner has presented the solution. So with this agreed upon verification, miners in the network can include a block of transactions to the chain. Now, why would a miner go through the trouble of solving this computationally expensive proof of work algorithm and problem and do the mining at all if it's costing them money with electricity and hardware requirements? So as a reward for doing the task of mining, the miner receives some cryptocurrency. Thus, miners are continually trying to mine new blocks in hopes of gaining this currency reward, which provides a system where transactions are added to the blockchain. This also gives the cryptocurrency control over the rate at which new blocks are added to the chain and how many transactions come in at once. By making this proof of work algorithm more difficult, they can slow down the capability of miners to add new blocks to the chain. Likewise, if blocks aren't coming in fast enough, they can make the proof of work algorithm a little easier, therefore speeding everyone's mining ability up. Now, you may have heard of mining rigs, which are essentially supercomputers with very powerful hardware designed with the sole purpose of mining blocks for cryptocurrencies. The goal is to rack up these mining rewards as a way to generate real profit. In all this talk of cryptocurrencies, the big elephant in the room left to discuss has yet to make its entrance, and that elephant in the room is Bitcoin. Bitcoin is the face of cryptocurrency today and was the first decentralized cryptocurrency created back in 2009. Its main features are those mentioned previously: the backbone of the blockchain, wallets with private keys and public keys for signatures, and it has a mining system with rewards with a proof of work algorithm. As more and more people around the world are starting to gain awareness of these revolutionary blockchain technologies, more and more people have started to invest their resources into Bitcoin. As of early 2018, a single Bitcoin is worth around $10,000. Just at the start of 2017, one Bitcoin was $1,000, and the year before that, at the start of 2016, it was around $400. So clearly, cryptocurrencies and blockchain technologies are on the rise. Now, beyond Bitcoin, there are many other cryptocurrencies that are taking the world by storm. Notably, there is the Ethereum blockchain and cryptocurrency, which has the second highest value for a cryptocurrency right behind Bitcoin. And not to mention, there's Litecoin, Ripple, IOTA, and thousands of others to mention, which have other aspects in addition to the core technologies of Bitcoin. But they all implement a blockchain, and for the most part, have the same core concepts of mining to support them. So, as blockchain technology itself is an innovation separate from cryptocurrencies, the applications for the technology are truly far-reaching and almost endless. Blockchains can also be leveraged to support fair and transparent voting systems. Some see the potential for the identification of individuals through documentation systems on the blockchain. Now, skeptics of blockchain technology will mention that the system is too complex for widespread adoption, and perhaps that humans are too attached to existing systems of transaction, such as modern banking, in order for blockchain technology to truly change the world. But years ago, the same was said for the internet, and it was met with the same amount of skepticism, as people predicted its total failure in the early 90s. And now it's impossible to imagine the world without internet. So perhaps in about a decade or so, it will be impossible to imagine the world without blockchain technology as well. Overall, blockchain technology is poised to continue revolutionizing the ways we interact with systems based on trust, especially economic systems. Therefore, to be best equipped to succeed in a blockchain-based future, what better way than to build our own blockchain and cryptocurrency?